Hi guys, this is lesson 8.1, adding and subtracting polynomials. Before we get into the new stuff we're going to review, you may remember from previous lessons that equations must have equal signs. Expressions do not have equal signs. So pause the video and go ahead and look at this little review section here and answer these on your sheet. Alright, for number 1 you should have gotten expression, 2 equation, 3 expression, 4 equation, and then 5 it says expressions with only numbers are always like terms. That would be true because like terms means that they have the exact same variable, and if they don't have variables then they are alike. 6 says an expression can have an equal sign. That is not true. And 7 says equations can be true, false, or open, and that is true. Alright, look at our vocabulary builder. As you can remember, a polynomial has the addition and subtraction of monomials. And for number 8, it says a monomial or a sum of monomials is a polynomial. 9 asks what test measures many tiny physical reactions of a person who is being questioned in order to determine whether the person is telling the truth. That would be a polygraph. And then 10, it says a triangle is an example of a polygon. So there are a bunch of polys for you. On page 486 of your textbook, note what the degree of a monomial is. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant is 0, and 0 has no degree. So what that means is when you look at a monomial, you take the degree of every variable that's in that monomial, not polynomial, but monomial, and you add them up. Just of the variables, not of the constants. So let's look at 1a. This is from your textbook. We don't see any exponents anywhere, and we really only care about the variable. So I'm just going to use my flashlight here and show the hidden exponent. And you can see that is 1. So that means the degree of this monomial, let's see, why isn't my pen working? There we go. The degree equals 1. Now for b, we can see that we have 2 exponents in this monomial. So if we add them together, we get 5. So the degree of this monomial equals 5. And then for c, we don't have any variables. This would be like if we had x to the 0 power, that would be 1, and 4 times 1 is 4, so we just don't see it. So the degree here is actually 0. So the degree equals 0. Alright, so let's go ahead and look at the got it. For 1a, or on your sheet, problem 11, it shows 8xy. So we can break this into parts. The degree of 8 is 0, the degree of x is 1, and the degree of y is 1, and we add them all up together and we get 2. Let's see if I can show that a little better. There we go. Alright, so the degree of 8xy is 2. So let's go ahead and look at 13. What degree is y2? What degree is z2? And then when we add those together, how many degrees is the whole monomial? Pause the video and go ahead and figure out both of the problems for number 13. Alright, you should have gotten 5 here because 4 plus 1 is 5, and this one you should have gotten 0 because there are no variables. In your book for problem 2, we're given examples A and B. Notice how these are like terms. Like terms means that the variables are exactly the same. If they're not alike, we cannot add or subtract them. If they are alike, we can. So since these are the same, we can just add them up and we get 8x squared. It'd be like 3 apples plus 5 apples equals 8 apples. So 3x squared plus 5x squared equals 8x squared. So for B, we look, our variables match exactly. This problem is a good idea to use our flashlight on. And we can see that we have 4x cubed y minus 1x cubed y. So that means we are just left with 3x cubed y. Oops, sorry. Stylus issues again. Go ahead and pause the video and do 14 and 15. Alright, you should have gotten 5x to the 4th and negative 5x squared y to the 4th. Take a look at this table on the bottom of the page. This is really helpful in helping us to consider the degrees and the names of monomials and polynomials based on their degree, and then looking at the number of terms. This will help us when we are trying to classify. Take a look here at problem 3 from your book. We are asked to write this in standard form and then state what the name of it is based on its degree and number of terms. Standard form simply means to put things in descending exponential order. That's a fancy way of saying the biggest exponents come first. So we would just say 4x squared plus 3x. We cannot add them because x squared and x are not the same thing. This is not 4 apples plus 3 apples. This is 4 apples plus 3 donkeys, and we do not have 7 donkey apples, so please do not try to add these together. This is in standard form, so now we look at the degree of our leading term, and that's 2. So that means that this is quadratic. You get that from the table that we just looked at. And then there are 2 terms, so that means it's a binomial. So we would call this a quadratic binomial. Okay, for B, I'm just going to rewrite this in descending exponential order. So look at your book and decide which would come first. The 5x cubed has to come first. It has the largest degree. Notice how we have a 7x and a 4x. We can go ahead and add those right now and say we have 11x. We can add them because they are like terms. Alright, we cannot add it to the x cubed. And then lastly we have minus 1. So it was tempting to think that this one had 4 terms, but once we combine the 7x and the 4x, we can see that we truly only have 3 terms. So the third degree means that it's cubic, and it has 3 terms, so it's a trinomial. And that's it. That's all we have to do to name this. So we put it in standard form, then we named it. Go ahead and pause and work on 17 through 21. Okay, you should have gotten that standard form was 8x squared plus 2x minus 3, and that this was a quadratic trinomial. Now let's talk about problem 4. Please read problem 4, pause this video, read the problem, and come back. Alright, the problem asks us, basically we need to add the two polynomials together. And I will share with you the vertical method because that seems to be everybody's favorite method every time I teach this class. The horizontal method leaves room for error, especially once we get into subtraction, because people forget to distribute the subtraction. So I'm just going to show you the horizontal method, and all we do is we write our polynomials. Oops, I feel like I made a mistake right there. There we go. And we line up, I'm going to put a 0.0 there because of adding decimals. We line up our like terms. So notice I put the x squareds under the x squareds, I'm putting the x's under the x's, and I'm going to put the constant under the constant. And then we just go ahead and add them up. So 21 plus negative 7.1 will give me 13.9 x squared. And then this will be negative plus negative is just a bigger negative, so 320x. And then we add those terms together and we get 7,700. Alright, go ahead and pause and do problems 22 and 23 on your sheet. I can see that they chose to use the horizontal method on the sheet. If you prefer to do it vertically, just do it on the side of your sheet and record your answer for 23. Okay, it was too difficult for me to write my answer in that little blank with the stylus, but you should have ended up with negative 12x cubed plus 120x squared minus 255x plus 6,022. Alright, let's look at problem 5. Problem 5 in your book shows us the problem horizontally, so make sure to look at that. And I want you to notice two changes I made to the way they wrote it. I made sure to include this and this. And the reason I did that is because I want to be considering like terms. So that will help me with lining things up to make sure it's like a placeholder. Alright, so notice this is subtraction. Here's the trick that I use when I do subtracting. If you like the way the book does it, you can do that as well. But this is a little shortcut I like to take. I turn this into addition, and then I change the sign of every number inside. 0 I don't have to worry about because 0 doesn't have a sign. So notice the 7 became negative, the 5 became negative, and the 12 became positive. And now I'm ready just to add like I did on problem 4. So I have 8x cubed minus 8x squared plus 5x plus 12. Oops, that should not be 8x squared, should that? That should be negative 6x squared because x minus 7x, or x cubed minus 7x cubed, is negative 6x cubed. So it's okay to make mistakes, just always go back and check yourself. Alright, go ahead and try numbers 24 and 25 and come back. Alright, you should have gotten negative 4m cubed minus 4m squared minus 2m plus 21. Go ahead and finish this sheet from here, so all of this right here, and I will check that in class and be ready to answer any questions you have.